can you solve this geometry challenge? Here's the question. Given these two squares having an area of A and B, if we connect this vertex to this vertex, it measures square root of 3. Now, if we connect this vertex down over here and this vertex, this length must be equal to square root of 7 units. Now, the question is, what is the sum of the areas of the two squares, or simply A plus B? Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so given this figure, we have here two squares having an area of A and B, and the distance between this vertex to this vertex is square root of 3, and the distance of this vertex of square A and this vertex of square B must be equal to square root of 7. Then what is the sum of the areas of these two squares? Alright, now to answer this question, let's call the side length of the square A be equal to small a, since all of this side is equal, because since it is a square, so all of this side must be equal to A. Now, the side length of this square B, let's call this as side B, or small b, like this. Now, let's call this angle over here be equal to theta. Since we have here 90 degrees, we also have here 90 degrees or 180 degrees. This angle right over here, opposite of this angle theta, must be equal to 180 minus theta. Now, from here, let's focus on this triangle. And then, let's use this concept. This is called the law of cosine. Now, the law of cosine says the square of a side of a plane triangle equals the sum of the squares of the remaining sides minus twice the product of those sides and the cosine of the angle between them. So we can say, given this figure, given this triangle, we can say that a squared equals b squared plus c squared minus 2bc multiplied by the cosine of alpha. And this is also true if we use the other angle. We have b squared equals a squared plus c squared minus 2ac times cosine of beta, and so on and so forth. But in our case, we are interested to the angle itself, so we will use this concept right over here. So we can say that cosine alpha must be equal to b squared plus c squared minus a squared all over 2bc. So we will focus on this identity. Now, given this figure, given this triangle right over here, using cosine law, we can say that cosine of theta must be equal to a squared plus b squared minus the opposite side, which is square root of 3 squared all over 2ab. Now, using again cosine law to the other triangle, we can say that cosine of 180 degrees minus theta equals a squared plus b squared minus, we have here square root of 7 raised to the power of 2 all over 2ab. Now, we will focus on these two equations. Now, let's simplify some terms a little bit. For example, we have here square root of 3 raised to the power of 2. We know this is just 3. And we also have square root of 7 raised to the power of 2. We know also this is just 7. Alright. And now, let's use some identities to this cosine of 180 minus theta. Now, take note, cosine of 180 minus theta is just equal to negative of cosine theta. So we can replace cosine of 180 degrees minus theta with its equivalent, which is negative cosine of theta, like this. And then, notice that we have here cosine theta and we have negative cosine theta. So the second equation, why not multiply both sides by negative 1? And if we do that, we get cosine of theta must be equal to negative of the quantity a squared plus b squared minus 7 all over 2a. And they are both equal to cosine theta. So we can equate them, of course. Now, let's distribute this negative sign to the numerator. And if we do that, we get something like negative a squared minus b squared plus 7 all over 2ab. Now, to eliminate this denominator 2ab, why not multiply both sides by 2ab? And if we do that, we cancel out the denominator 2ab. Now, let's focus on these results. Now, let's combine similar terms. Take note that we have here negative a squared and positive a squared. So just add positive a squared on both sides to make this equal to 0. So we have here 2a squared on the left hand side. And then let's add b squared on both sides to cancel this out. So this turns out to be 2a squared plus 2b squared minus 3 equals 7. Then just add 3 on both sides. So this will give us 2a squared plus 2b squared equals 7 plus 3, and we know 7 plus 3, this is just 10. Now, factor out this common factor of 2. This is just 2 times the quantity a squared plus b squared equals 10. Divide both sides by 2. So we have here a squared plus b squared equals 10 over 2, or simply equal to 5. Now, we know that a squared plus b squared must be equal to 5. And going back to our figure, since the side length of this square A must be equal to small a, so we can say that a squared must be equal to capital A, or the area of this square, and b squared must be equal to capital B, which is the area of this square B. So we have a squared, this is just a, we can replace this with a, and this b squared, we can replace this with b. So we can say that a plus b, this is what we want to find. A plus b, or the sum of the areas of these two squares, must be equal to 5 units. And that is the answer to this question. Therefore, given this figure, the sum of the areas of these two squares, or a plus b, must be equal to 5 square units. And as always, we are done.